Just so you're aware, this is Abbie Smith coming from Oklahoma to talk about viruses, but there's also an extra piece here, is that today is Abbie's birthday. So everybody say happy birthday.
Happy birthday.
All right, this is Abbie.
Great, thanks. For those of you who don't know me, I'm a graduate student at the University of Oklahoma, and I study HIV, how it evolves, and how to different angles for creating vaccines. So today I'm going to talk to you all about vaccines. So just for an analogy, I think it's totally normal to be afraid of flying in an airplane, because when you look at it from a very superficial perspective, you're sitting in this aluminum can that's getting hurled through the air, 20, 30,000 feet above the earth, tens of thousands of miles per hour, whatever, like it's just so fast, and you can think of so many things that could go wrong. It's really scary. But when you start to learn about the science of flight and, the safety precautions everybody goes through and the training that people have, and then you look at the statistics of, how many people die in airline crashes every year versus the number of people who die, just crossing the street, it's not that big of a deal. So while I think it's normal to be afraid of flying in an airplane, it's not entirely rational. So I think it's totally normal for people to be afraid of vaccines or to have concerns about vaccines, because viruses are these teeny tiny alien creatures that you can't see and you can't avoid, and they make you sick anyway. And now we're taking these viruses and putting them into vaccines and injecting you with this stuff and these chemicals you've never heard of. So I think that's totally normal. But what I want to do is talk to you all today about vaccines and the science of vaccination, and address some of the concerns that some of you might have to, get rid of this kind of irrational fear of vaccines. So the first thing is, what are we trying to prevent with vaccines? So pathogens are generally the bad guys, the small bad guys. So whether it's a bacteria, a fungus, a virus, anything that causes disease. So, for instance, a bacteria might be bad and cause disease in one circumstance, but that exact same bacteria could be a normal part of you and who you are. Like, we've all pretty much got drug-resistant staph, on our bodies or in our bodies, but we have so many normal, helpful bacteria to kind of keep these guys in check that they don't cause any disease. So when I'm talking about a pathogen, in this case, I'm talking about something that makes you sick. So obviously, we all know we're susceptible to pathogens. We've all had, a little patch of ringworm or have gotten an infection in a cut, but we aren't all, bacteria food. We get over these. So we can do that because our body has these innate mechanisms for protecting ourselves and getting over these infections. And of course, the first line of defense is to not get infected at all. And that's why we have skin, that's why we've got mucus, that's why we've got tears. It's to wash the bacteria out, to make the bacteria get stuck in your mucus so when you sneeze, they can't get inside. But obviously, that's not enough. So we have a branch of immunology, the little cells in your body, that they're kind of like sensors. Think of it like a motion sensor that's looking for something very specific and looking for something that's wrong. So for instance, humans, we carry our genome as DNA. That gets turned into a message that's RNA, which gets turned into proteins that builds us, what you see here. Well, bacteria, sometimes they coat their proteins in sugars that humans never ever make. Or viruses have double-stranded RNA, which humans never ever make. So you've evolved these mechanisms to look for double-stranded RNA and looking for these weird sugars to set off your immune system. It knows it's been invaded. The innate and intrinsic immunity is something that's all plants have. And of course, plants are getting along just fine. But humans and other animals, we have another layer of our immune system, which is adaptive immunity. A lot of people in the skeptical movement, we were just talking about this at lunch, are very familiar with evolution and arguments for evolution. And if you understand evolution, you understand this branch for your immune system. So this branch actually evolves and learns in response to the pathogens that you've been exposed to, in the sense that, there's all these mutations when an actual infection is occurring, and your body actually selects for the variants that protect you better in the future. So let me just go through a little quick example. This is composed of T cells. So when you think of these guys, think of tanks. They go around looking for cells that have turned into cancer or have become infected by viruses, and they don't so much blow up cells, they don't kill cells, as much as they persuade these cells to commit suicide. And they do this through evolution, because I don't have a pointer, but the connection that's being made there, a cell will put out flags that says what kind of proteins it's making. Let's say we're talking about a neuron. It's saying, I'm making these normal neuron proteins. But if it becomes infected with a virus, it'll start putting out these virus proteins that look like pirate flags. And your immune system, just by chance alone, has some of these T cells that recognize that pirate flag and know to tell that cell to kill itself. We also have B cells, and these guys release antibodies that can coat the surface of a virus or coat the surface of a bacteria to tell your immune system that this is a bad guy, he needs to die. So that's just what I'm showing here, is that, in a normal infection, a virus interacts with a receptor, it infects a cell, you make new baby viruses. Well, if you've got antibodies that recognize that virus, it coats the outside so it can't interact with the receptor, and you functionally stop the infection. Well, how do you get antibodies that recognize a virus? Where did those light blue guys come from? Well, just by chance alone, you've got B cells in your immune system right now that recognize sort of, not good, but kinda, this light blue virus that I've got shown here. And so the B cells that make this sort of dark blue that sort of recognizes the light blue antibody, it competes for survival signals. It competes for these chemicals that tell the cells to reproduce. And so it does reproduce. And its offspring are just a little bit different than what the mommy and daddy B cell was. And so now we've gone from this dark blue to a slightly lighter blue. So that guy gets selected, and he creates progeny that may be a little blue-green, a little darker blue again, but then another light blue. Well, that guy gets selected again until you ultimately get a B cell that makes antibodies that are really, really good at neutralizing this virus. And, these guys stick around for a long time, so the next time you're exposed to light blue virus, you don't have to get sick again. And that's ultimately the problem with this process, is that for it to occur, you have to get sick. And that becomes problematic when you're dealing with viruses and bacteria that kill people. It's once you get sick, that's it, that's the end. So that's where things like vaccines come in handy. So vaccines are either dead pathogens, weakened pathogens, or just chunks of pathogens that we use to train your immune system to fight the bad guys without you actually having to get sick. And like I said, this is particularly useful for pathogens that kill you or have very severe side effects, is that you never want to get sick in the first place. And that's what we can do with vaccines. Well, that's fantastic. I mean, every single generation that comes along, their normal childhood diseases, that list is getting shorter and shorter and shorter. So kids these days don't really understand what chickenpox is. They haven't had it, their friends haven't had it, they know they got a shot for something, they don't understand. People my age, we've never gotten measles or mumps, I wouldn't even know what that looked like. The generation further down, when they went out in the summers, they didn't have to be worried about catching polio. I mean, we're worried about breaking our arm and, you've got your arm in a cast and you can't go swimming all summer. Well, when polio was rampant, you were worried about, getting a lifelong disability. And because of vaccines, we don't have to worry about this stuff anymore. It's fantastic. So for the longest time, this was pretty much a non-controversial issue. Beekman's World did an episode February 1993. This is a children's television show. He did this like 8-minute bit on what vaccines are and how they work. And I fully suggest you go watch it. It's on Netflix streaming. But that's how non-controversial vaccines were, is that you could do a little kid show on it and, nobody batted an eyelash. But then things changed. February 28th, 1998, this fellow by the name of Andrew Wakefield published a paper that tried to connect vaccines with autism. This paper was subsequently retracted. Literally no one else on the planet can find a connection between vaccines and autism. But the mayhem that this guy started set this chain reaction into effect, where there are parents now who are really concerned about getting their kids vaccines because they're afraid that something bad might happen. So I want to say there's a difference between people who are just concerned or don't know a lot about vaccines and then being wary of vaccines, and the people like Andrew Wakefield or Jenny McCarthy who make a living putting out misinformation about vaccines. And so I think one of the problems we might run into a bit in the skeptical movement is that people might have genuine questions about vaccines, but they're afraid to ask them because they don't want to be labeled, like a Jenny McCarthy sympathizer. So I wanted to address just a handful of claims that I think some of you might have come up against to answer your concerns, and maybe when you go out you can address your friends' concerns as well. So one is, why does it matter to you whether my child is vaccinated? What's it matter to you whether I'm vaccinated? This is a personal decision. It's none of your business. Leave me alone. Well, remember I said that the evolution of your immune response, it's like normal evolution. It's random mutation and natural selection. So that means that each one of us in this room right now, you could give us the exact same vaccine, and we're all going to make different antibodies in response to that vaccine. Now, they might all be right, but they're going to be right in different ways. And so let's say that these 8 people, they're a group of friends, they hang out together, and they're all responsible citizens who got their vaccines. Well, these 5, remember we're looking for an antibody that neutralizes the light blue virus. They've got B cells that get pretty close to being a light blue variant. However, just by chance alone, some of these people aren't really going to go down the right evolutionary pathway. I mean, we're talking about random chance here. So this poor waiter is making more of a light green antibody, where the police officer is making kind of a purple-pink. If ultimately they were exposed to the pathogen, they might not get as sick as they would if they hadn't gotten the shot, but they're still going to get sick. And then there's this poor carpenter here. He got the vaccine, but he didn't make an effective antibody response. He didn't do anything wrong. There's no supplement he can take to boost his immune system. It's just the fact that we're dealing with random chance and the combined effect that we're injecting people with dead pathogens or chunks of pathogens. There's no real reason for your immune response to respond appropriately to that. It's just this dead thing floating through your bloodstream. And if your immune system ignores it, it doesn't care. And a person who doesn't make a response to a vaccine one year might get a booster shot the next year and respond just fine. It's like, what I really want to emphasize here is kind of the randomness and how we don't exactly know. Even myself, I've gotten the MMR, but I don't really know that I've got protective antibodies to measles. So what happens is if all of a sudden these 5 people decide that, they're going to skip the shot this year, or they don't believe in vaccinations, or it's against their religion. Now all of a sudden, these 3 individuals who were responsible and did get vaccinated, they think they're protected, and they're really not. So this photographer might go on a mission trip to Africa. She comes back, and literally everyone in this picture is going to get infected. So whether you get vaccinated or not is not really a personal decision. Like You know, if a Jehovah's Witness would rather die than accept a blood transfusion, or if a Jewish person would rather die than accept a heart valve transplant from a pig. Those are personal decisions. But to not get vaccinated is a personal decision, like driving drunk on the road is a personal decision. Your decisions have negative effects for other people. Just a quick story, there was a play school, kindergarten pre-development school, that required all of their children have vaccinations. And they had a group of children whose parents forged their vaccination records, and these kids come in one day with chickenpox. Well, one of the women working there was pregnant, and she didn't remember whether she had chickenpox or whether she had gotten a vaccine. If those children infected that pregnant mother with chickenpox, she would have lost the baby. And those parents who forged the records just didn't care. They didn't think about the negative effects their decision could have on other people. And I don't think they should have that right. And places like California are at least making it more difficult for people not to get vaccinated. Before, you could just, sign, say, I want a religious exemption. Whereas now in California, you have to sit through a lecture by a physician before you're allowed to say that you don't want the vaccine. Okay, so another concern people have is that babies and kids are getting so many vaccines these days. I mean, think about it. You've just had a baby, take it off, and she gets all these shots. And then you come back for another checkup, and she gets even more shots. And you come back a few months later, and she gets more shots. I totally understand why parents would be concerned about their babies getting so many shots at once. And so one of the phrases from the anti-vaccine movement to go along with this is too many too soon. Well, the easy response to that is that we've studied exactly how and when we need to give vaccines, and there have been no correlation between adverse effects and when you get the vaccines. So if you follow the CDC's recommended schedule, everything should be fine. But just to explain why, remember again that in this little process I showed here, we started with this dark blue antibody and ended up with a light cell that released the light blue antibody. Well, let's say we've got a vaccine, or you're getting 3 shots at once, and one is against a light blue virus, one is against this big green bacteria, and one is against microscopic little pink elephants. You're getting all these shots at the exact same time. Well, the blue cell, the blue B cell, only sees the blue virus. It doesn't know that the green bacteria and the little pink elephants even exist. It's in its own little world. It's like, it doesn't care that these guys exist. Same with the green guy, same with the pink guy. So ideally, as a virologist, what I would like to do is put 5,000 vaccinations in one shot. So you didn't have to get all these different vaccinations at the same time. You didn't have to get booster shots. Like, in my mind, the best vaccine is one that you give once and the person can walk away. But the problem, again, is just to reiterate, your immune response is random, and we're dealing with dead and weakened and chunks of pathogens. So the concern is really not that the baby is getting too many vaccines, but that if you give too many vaccinations at once, their immune system is going to ignore, let's say, the pink elephant and the bacteria, and only focus on the blue guy. So what's the point in giving a vaccine that contains 3 ingredients if your immune response is only going to respond to 1? So the reason why shots are spread out like that isn't so much to protect the baby, it's to make sure the baby actually makes an immune response and those vaccines actually work how they're supposed to. Oh, the toxins. No one wants to inject their baby with toxins. Think about the toxins. So this is a list I got off of Mercola. He's this Fruit Loop guy on the internet. Yes, Vaccines don't poof into existence. We have to use cells to make these proteins, make the viruses. Those cells need food. They need certain selective markers. Then we have to kill those dead viruses somehow. We have to purify those proteins somehow. So yes, these ingredients are in trace amounts in vaccines. So once again, ideally, we would love to give one shot at once to minimize your exposure to this stuff. I mean, just like a multivitamin has fillers and stuff to make it more soluble, that sort of thing. But yes, what I'm really going to focus on this ingredient list is the aluminum, because that's one that really freaks out the anti-vaxxers. Scientists aren't like melting down recycled aluminum cans and putting them into vaccines. It's like when people say things like that, like, oh, they're putting aluminum in vaccines. Like, think about it. Just think, why would a scientist do that? Well, because we're not doing that. We're using something called alum, which is called an adjuvant. And what adjuvants do is they make vaccines work better. For the millionth time, we're putting in weak, dead, and chunks of pathogens. If I took a vaccine and just left it on this podium overnight, we'd come back the next day and the proteins would be degraded, like bad things would have happened. So if you take a vaccine and inject it into someone, a harsh environment of the bloodstream, it could degrade. Your immune system could not react at all, and you wouldn't get the protective immune response. So what we do is we do a little trick. One of these tricks is adding adjuvants. They kind of get your immune system's attention, so it responds to whatever's in the vaccine. So some of the ways it does that, it's either longer exposure to whatever chunk of protein you put in. It kind of pisses off the immune system a bit and gets its attention, and you start getting those survival signals that the B cells need to make you good response. My point is, it's like when you see a list like this, think about it and be like, we aren't just putting this stuff in for fun. There are ingredients in vaccines that might look scary, but we're doing it for a reason. So, what I want to actually do is take as many questions from the audience as I can about your all's concerns about vaccines or questions about viruses and that sort of thing. I don't just want to lecture on the stuff that anti-vaxxers say. I want to hear what you all actually have questions about.